Hi everyone, my name is Yuki. Welcome to this container security session. Security is critical to any organization, and container security is quite different from your traditional IT security. In this session, I will explain some common security challenges that we see from many enterprise customers. We'll explore securities around containers and Kubernetes, what you should think about while you adopt to containerization. And then I'll talk about our solution in this space, NewVector. I'm a sales engineer based in Toronto, Canada. I've been helping customers with containers and Kubernetes for over 5 years. I'm really excited to share some insights on the security side with you today. Containers and Kubernetes are great to host your microservices, automate many aspects of application deployment, and they're very popular, right? However, the architecture is quite different. So the security considerations around that are fairly new to everyone. It brings new risks that can expose your business to attacks, which may lead to great loss of millions of dollars. Hackers could use their old tricks, like man-in-the-middle attack, to the container world. And there are also new tricks, more and more container-based exploits. Even though people become aware that they need security built for containers, we still see many challenges that a lot of customers are facing. Where should we start? What factors should we think about? What factors should we look into? It's complicated with so many different components. A big challenge is that traditional security tools don't really work well in this environment. Many solutions are based on scanning the application layer and don't cover securities around file access, processes, and networking layers. It's hard to find a comprehensive solution you can use to solve all these issues. And many enterprise security teams tend to push security onto DevOps. But DevOps knows little about container security, and developers should be coding for the business purpose and spend less time on security measures. What about your traffic, right? How do you inspect your east-west traffic across Kubernetes? Can you protect before the attack occurs? These are also challenges to many organizations. And that's why we see requests on auditing, compliance, vulnerability scans, security around the CI/CD pipeline. Customers look for network inspection and visualization for a dynamic environment. Some require easy integration into existing workflow, right? This is just one example to share with you here. And in fact, all these considerations should also be applied to your container environment. They should be on your checklist too. First of all, let's take a look how container works. What are some key components and security around each component? The life cycle starts with the code. Developers create application code, which is likely to include third-party dependencies, and vulnerabilities could exist as early as this stage. Then your developers may build a container, or a DevOps engineer may just package it with a container for deployment. And during this build process, there could be poor configurations that lead to being attacked later. Something like configure the container to run as root user, give it more privilege on the host than it really needs, put sensitive data such as passwords in the container image. Remember, anyone who can access a container image can also access files included in those images. So you need to make sure not to store sensitive information there. You want to make sure that you don't misconfigure anything to expose yourself to potential attacks in the future. You want to make sure the build process is secure and the build machine is secure too. And after you build your image, you want to store them in image registries. It's critical to scan the images and also scan those registries because you want to make sure other people in the team are using images without vulnerabilities. If you use private registries, you need to add access control to identify who can access, who can push, who can publish the images. You don't want unauthorized users to modify, to publish, or delete your images. You could also sign your images. It's a way to associate identity to your image. The signature tracks image and show you who signed it. You should also think about securities around your host system and kernel. Secure your deployment. Secure that container runtime. So we'll talk more about runtime later, okay? The point here is that the container comes with different components, and container security is a holistic process. This picture also includes CI/CD pipeline. Here, you need to integrate security with all these steps to make sure your security can scale out with your containers. You may have hundreds or thousands of container images in the registry, so your container scan should be able to handle that very quickly and easily without slowing down. And then continuously scan in production to find new CVEs as they publish. Other important factors are around container orchestration and the runtime. Once you implement Kubernetes, you need to consider securities around Kubernetes as well. These are some examples of potential vulnerabilities on the Kubernetes side. Something like application configuration could lead to attacks in a container, and then the hacker could probe for weakness in the network or file system. Unauthorized connections between pods. Hackers could connect with other running pods through compromised containers, right? So in that case, layer 3 protection is not enough because hackers could attack over trusted IP address. You also need layer 7 network filtering in that case. And then think about your data. It's a risk that your sensitive data gets stolen or removed, copied, transferred. And then some compromised container could start malware such as crypto mining or processes like scanning your ports or injecting some binaries. Suspicious libraries or packages could be installed to exploit containers. Your files could be changed. Also, on the host level, Kubernetes nodes could be compromised too. There are vulnerabilities on the operating system level, on your Linux kernel level. So that's another layer you should think about. And you know what? The scary thing is it could be series of attacks in multiple layers, not only on containers, but also in your Kubernetes, your networking, your host level. There are also attacks on the Kubernetes infrastructure side, like compromised API server, kubelet, etcd. So the containers in the pod and the infrastructure side, you should think about multiple layers in terms of container security. Here's a list that you can review and get started with. Configure RBAC, role-based access control for system resources. You could configure access control for the API server, kubelet, check your external ports, remove unnecessary ports, and add authentication for external ports. Auditing, compliance is also very important, right? There's a comprehensive set of security checks, tests, benchmarks you can run for containers and security, Kubernetes security. Now, so far, we've talked about securities based on how containers and Kubernetes function and based on major components of this infrastructure. We talked about container images, registries, Kubernetes resources, and nodes, right? These are fundamental parts. Beyond this, you should also think about your whole pipeline, from build to test to production, across different environments and different phases. It really should be a full lifecycle protection, a holistic security approach, and it should be automatic. You can see there are two major components here. First of all, vulnerability and compliance management. So the idea is that a vulnerability scan should be triggered in the build phase in your CI/CD pipeline, so developers can remediate those vulnerabilities before the image goes to registry. And then there should be continuous image scans in your image registry. We do compliance scan on all major standards like PCI, GDPR, NIST, HIPAA. You should do vulnerability checks like CIS benchmarks or file access permissions. There's a little bit about CIS benchmark, just for those of you who are new to security, okay? It is published by the Center for Internet Security. It's best practice on how to secure Kubernetes. Very detailed recommendations on configurations, like how to configure your worker nodes, kubelet, how to secure your control plane, including API server, controller manager, etcd, some recommended settings and policies for RBAC, CNIs. So make sure to run this test regularly. And secondly, runtime protection. Runtime security should provide active protection while your containers are running. You should be able to detect and prevent malicious activities. You should be able to stop them. Admission controls prevent vulnerable images from being deployed. Create rules to enforce deployment from a certain registry or allow only certain users or service accounts to deploy containers. And then container firewall. It's like extending the traditional firewall security concept to your Kubernetes. There's still layer 3, layer 4 filtering based on IP addresses and ports. There's also layer 7 container firewall, which does filtering and deep packet inspection of interpod traffic. The protection is based on application protocol and built-in detection of some common network-based attacks like DDoS, DNS, SQL injection. You should have something to protect web-facing containers like HTTP, HTTPS-based applications. You should have something that does in-depth network security in your containers. Looking for things like malicious HTTP request or any executable shell command, right? Your container firewall should determine if each pod connection should be allowed to go through or should be blocked. You should also inspect container processes and file system activities, detect if there's any suspicious behavior, right? Something like port scanning, reverse shells, or privilege escalations. Also, make sure to apply least privilege and allow connectivity only between containers that need it. Host level security are also very important. Your host systems, that's where your whole workload is running. Make sure your host systems are monitored and protected. And then security automation. It should be through behavioral learning and security as code. So in your pipeline, you could declare allowed behaviors or do it through a behavioral learning process when you run your workloads, and then create all the allowed behaviors based on applications. And then leverage security policy as code for your cloud-native pipelines. So you can integrate security policy throughout your CI/CD pipeline. That means you don't need to go through manual process every time when you open a port, right? Instead, you can implement security as you scale without slowing down your pipeline. All right, I'm going to talk a little bit more about runtime security. What we see is that when it comes to runtime security, many organizations still have some gaps in the coverage. You can see two different models here, threat-based control, zero-trust behavior-based control. Threat-based control is reactive. It's based on past vulnerabilities, like CVEs. When you do a vulnerability scan, you have to know CVEs. And many of them will come with a remediation, a patch, a fix, update. You have to know this threat first. Scanning is necessary, and you should do it regularly. However, scanning alone is not enough to protect you. It won't give you visibilities into processes or network behaviors. So you won't get zero-day protection either, because these threats that you are aware of already happened in the past. Before you take actions, you have to know who's trying to get in first. What about unknown threats, right? Those new threats that they're not even published yet. It takes time to publish threats for people to scan against. What about a CVE that doesn't have a patch, right? And behavior-based security, on the other hand, relies on the behaviors of yourself. So you should know your applications well. You should know where your customer data is. You should know what your microservices do. Is it a database service or something else, right? An application behavior will define segmentation and identify anything else that is not your normal activity. This model will help you block unpatched CVEs and block any unknown behaviors, any suspicious behaviors. Runtime protection is based on this model. The behaviors of your applications is proactive. You can protect the containers running in an environment that is even impacted by some vulnerability. So even though you scan your environment, find vulnerabilities, and haven't got a chance to patch that CVE, or when a certain CVE doesn't have a patch available, you could still protect your running containers. I'm not saying you should just forget about that vulnerability. You still need to fix it, but it's an extra layer of protection. That's another reason you need runtime security on top of that regular scan. Runtime in Kubernetes, this is significant. Inside of Kubernetes, it's hard to see network traffic. As you may be aware, there's an explosion of east-west traffic because Kubernetes abstracts away the complexity of this container-to-container traffic, so you lose visibility of the traffic. Other products in the market may tell you what is represented in a manifest file or in IP tables or use port labels, right? Some may even filter out everything happening on a kernel level and try to represent what is happening within containers. You could get layer 3, layer 4, send and receive commands from the kernel, but none of these approaches are looking at live network traffic. And they don't see if network connections are being made without their knowledge or permission. You may have great visibility on your ingress, egress, that north-south traffic. You have traditional security firewalls, but that level of security cannot inspect or see into traffic within your Kubernetes. So you don't want any containers or services exposed to the open internet and open a path for any suspicious activities or attacks. So you need to have a tool to inspect your east-west traffic. You need to see what's going on inside your Kubernetes. Zero trust. You may hear about zero trust a lot. It's the model we use in container security. It's not like the traditional security model, which assumes everything behind the firewall is secure. Zero trust model assumes that all entities are untrusted by default. Never trust, always verify even your internal traffic. Do not trust even when the request is authenticated, authorized, or encrypted. Always verify before you grant access. And make sure to use the least privilege access. Enforcing real time is critical. Hackers will try to hack your environment, stealing your customer information, running crypto mining, and all kinds of bad behaviors at that runtime. So you need to enforce the policy and block attacks in real time. Something like network attack, hackers could do port scanning, get your public-facing microservices. You should block it when your ports are being scanned. Don't wait until attacks get into your container and start to consume resources. Discovering that behavior pattern is significant. Then you can move it to zero trust. You can switch to monitor or protect mode. You can alert or deny on any anomalous behaviors. When you scale out containers, you could scale out hundreds or thousands of containers. So your security needs automation for the same level of scalability. It should be integrated with your pipeline and workflow, so security won't slow down any process. You don't want security to become the bottleneck. All right, that is an overview of container security. We went through some ideas how you can better secure each component of your pipeline. We talked about vulnerability scans and runtime protection. If you have a comprehensive plan to secure your environment, that's great. Make sure your existing tool helps with both scans and real-time. Otherwise, if you're new in this space, you can always refer to the content from this deck and start to build from there. Now I'm going to introduce our solution, NewVector. NewVector is a container security that does both scanning and real-time protection. Our scanner is very fast and accurate. NewVector is very unique in end-to-end full lifecycle security with automation, network inspection, deep packet inspection. We deliver data loss prevention for cloud native. We're an expert on runtime security. And NewVector is deployed as a container in your environment, as Demon said. We don't use sidecars, so it scales really well. It's very easy to scale out or scale down as you add or remove more nodes. We actually passed the test to scale 1,000 nodes per Kubernetes cluster without any impact on application performance. For Rancher users, the latest NewVector release integrates with Rancher really well. You can deploy it directly from Rancher today. It's also very easy to implement if you use other container solutions like OpenShift, Tanzu, GKE, AKS, CKS, and other major container platforms. NewVector does vulnerability and compliance scanning. We can scan early in the pipeline at build time. We can protect when your image is being built. Once it passes the build, we can scan registries where images are pushed to. We can scan layers. We can identify where vulnerabilities are in your images. Then we have admission control, security policies, something like pod security policy. When you run those images, we can scan your containers in the runtime. Scanning is great. You review attacks that already happened from the past and prevent it from happening again. However, it takes time to check for CVEs to be published. Or remember, you may not even have remediations right away. That's the limitation. And that's where traffic inspection detection can help. We're the best on this. We hold patent. All zero-day attacks can be detected. We're able to check your running containers, pods, and also your node. NewVector is able to see what's going on inside your Kubernetes traffic. You can inspect, you can detect layer 3, layer 4, and also layer 7 through deep packet inspection. We also collect every process that runs from containers. Technologies like eBPF is very cool and offers some good security features. We use it for certain non-network functions. We don't rely on it, especially for a true layer 7 firewall. So eBPF is limited in protocols and deep packet inspection. We do this in real time. We build security rules in real time. We can learn your behaviors, generate security policies, and that's why we can block certain traffic before it hits the kernel. We don't run any sidecars or depend on any specific CNIs. So we're also compatible with almost all CNIs and service mesh. There's a zero trust network, process and file protection for day 0 before a CVE is published or remediated, or protect your containers from your internal users. It identifies appropriate container behaviors and only allow whitelisted network connections, processes, and file access. Let's say if you have a database service running without protection, a user within your organization could suddenly run commands to gain full control of the server or start to copy data. That's not normal. And NewVector will know that behavior and block it before it happens, before the damage is done. Lastly, I'd like to point out that NewVector has been approved by the Department of Defense Iron Bank and is now available through the Platform One application portal. The Iron Bank is a repository of security-hardened container images that are certified for DoD application developers to deploy. Here are some useful links to documentation, image that you can download and try in your environment, and a Slack channel where you get community support. Also, feel free to reach out to us if you have any questions, if you need any help with the design or advice to your specific use case. We'd like to help. All right, I hope you learned some basics of container security today. Thanks for watching. Bye.